On this slide, we record some algebra of functions. So you take two functions f and g. F and g both take some arbitrary set a to real numbers. So first let us talk about addition of functions. F plus g x is equal to f of x plus g of x. So this is something which you already know, and as I will write an example you will see. So you have functions f and g going from some arbitrary set a to real numbers r. Both f and g go from a to r. So now an example. Say now we have fx is say x square and gx is just x. So as you would have guessed it, f plus g of x is nothing but x square plus x. So we are just codifying what you already know about functions. So there is nothing special about them which you haven't seen before. So here the set A is also real numbers. So f is taking real numbers to real numbers and g is also taking real numbers to real numbers. F minus g of x is fx minus gx, and again you would have guessed what would happen with x square and x. Now f multiplied with g So in terms of examples, you can see so as you can see, it follows the same laws of functions as we did before in school. But we are writing the algebra of functions because we have defined functions from scratch. That is, from sets we defined Cartesian products, and from there we defined relations, and from there we defined functions. So if you have functions as a tuple and you define all these algebra of functions, you will get exactly the same results what you got by defining functions as something like x or x square before you knew precisely what functions were. So we are just writing it down so that you are clear of what algebra of functions is when we define functions from the set theoretic form. So again you have f divided by g of x. In the previous one we have c times f of x, where c is some constant, and in the example I have taken the constant as the integer 3. So whenever you divide, you have to keep the denominator as non-zero. So here also we will write it in such a way. So this will again be x squared divided by x, and the denominator is non-zero. So this x in the denominator is non-zero. Yeah, gx is not 0, and then this x is not 0.